Hi everyone. Today we congratulate our wonderful authors of Editors of the Choice article. We will let author introduce themselves and thank you so much for being here. Yes, please introduce yourself and tell us a little bit where you are right now.
Hello, my name is Tessa de Vries. I'm a PhD candidate in the Erasmus University Medical Center in Rotterdam. And during my PhD, I investigate the effects of CGRP and CGRP receptor blockade in human vasculature, and also developing a vessel-on-chip model to be able to study patient-specific responses to CGRP and CGRP medication.
My name is Antoinette Maassen van den Brink. I'm a professor of neurovascular pharmacology at the Erasmus Medical Center in Rotterdam. I'm the supervisor of Tessa's PhD trajectory, and she's nearly defending her thesis, so she did really, really well, but she will stay as a postdoc. So I'm very happy with that. And besides my work at Erasmus MC, I'm also the president of the European Headache Federation.
This is amazing, and thank you so much. I am Dr. Nina Rigens, and I am social media editor for the Journals of Cephalalgia and Cephalalgia Reports. And I'm talking from California, and this is such an amazing opportunity for our audience and all of us to learn about your wonderful research and article about sex differences in responses of different arteries to CGRP. What brought you to this work? This is such an amazing achievement.
Thank you very much for having us here today. Over the past, I think, 22 years, we've collected a lot of human tissues, and we've performed a lot of experiments with them. Our lab is focusing on calcitonin gene-related peptides, CGRP. And for this study, we thought we want to look at whether we can see any sex differences in the responses to CGRP. And because we have this amazing, huge database, we had the opportunity to actually look into back to see whether we could find these differences. Because of course we know that there's a difference in migraine prevalence between men and women. And we also know that CGRP levels can change during life, but also vary between men and women. So we hypothesized that we could find differences in CGRP response in this vascular tissue. And that's why we wanted to investigate it here.
And maybe to add on a more sentimental note, Tessa already mentioned that it's work from the past 22 years. Now, Tessa was hardly born by then. But I was already at this lab, but that makes it for me also very special because we really compiled work from Tessa, who did a lot of work on this, but also from earlier PhD students who are also co-authoring this paper. So that makes this paper especially dear to me.
Yes, thank you so much for that. How was this work structured? What were the methods?
So we obtained human tissues. We have human coronary arteries from our collaboration with the Heart Valve Bank. So they take out the heart valves and we get the heart brought to our lab. Then we isolate the human coronary arteries. And we also have a collaboration with neurosurgery from which we obtain middle meningeal arteries. And then both arteries we can store in this Krebs solution, physiological salt solution, to keep the arteries alive. Then we clean the arteries and we cut them into small segments, which we can then mount into our myography setup. We put two metal wires through the vessel and then put it in the setup, which allows us to measure the tension on the vessel wall. And then we can add certain compounds, in our case CGRP, in increasing concentrations, and then construct the concentration response curve to CGRP and see the relaxation of the artery. Of the different arteries in this case, so the human middle meningeal arteries and the human coronary arteries. I think in total we had 62 human middle meningeal arteries and 139 human coronary arteries over all these years. So that's a huge amount of data that we obtained all during this, doing the same methods of experiment.
And Tessa's being modest, but what she's not mentioning is that, of course, we don't have any control over when these arteries do become available. So it's really often that neurosurgeons operate on Friday afternoon. And really, Tessa has spent quite some evenings and weekend days also on the lab, because yeah, you cannot keep the tissue. You should really investigate it when it's fresh. So it's really, really demanding to do such studies in human tissues, because it really takes lots of effort to have the contacts to receive the tissues. And when it comes available immediately, you should start working for a whole day or night or evening. So yeah, really well done.
Thank you for your dedication to research and doing this unbelievable work. I looked at the article multiple times and I was astonished by wonderful diversity of participants who was enrolled there, because you had groups of participants before 50 years of age, after 50 years of age, and males and females. And what did you find?
Yeah, we hypothesized that we would find differences between men and women, and we also thought that maybe hormonal influences are involved here. So that's why we want to split the women into two groups, the premenopausal women and postmenopausal women. But unfortunately, we do not have the menopausal status of the tissues we receive. It's all anonymized, and we only receive the age and sex of the donors. That's why we decided to make a division at the age of 50, so that we have approximately pre and post-menopausal groups. And thereby we also categorized the men into the same two groups. So we had 4 groups: below the age of 50, men and women, and above the age of 50, men and women. And then when we go to the results, we did not find any differences between these 4 groups in the human coronary arteries, so no effect of sex or age. But when we look at the human middle meningeal arteries, we did see differences. So the young females showed a very much smaller response and less potent than in the young males, especially. In the older groups, so older men and women, we did not see differences, but the young females and the young males were really different.
That is so fascinating. And I love the just give teaser to our audience. There is beautiful picture graph in your article about hormones, estrogen, testosterone, and hypothesis. Why did you see these findings? Can you tell us a little bit about this?
Of course, yes. So indeed, we hypothesized that sex hormones are causing these differences that we see in the human middle meningeal arteries. Because we know that in young women, estrogen levels are high, testosterone levels are low. And yeah, it's been described that estrogen affects CGRP levels as well. So here we hypothesize that when there's high estrogen levels or high fluctuations of estrogen levels, that this also results in high CGRP levels. And then when there are high CGRP levels, this could result in receptor desensitization or downregulation, thereby having maybe less receptors present. And if we then add the exogenous CGRP in our myography setup, then the response in the young females is smaller. However, when the women become older, the estrogen levels and fluctuations decrease a bit. And then we hypothesize that there's less receptor desensitization and then a larger response in our exogenous CGRP assay. And in men, it's actually the opposite. We hypothesize that there's high testosterone levels, resulting in maybe a high expression of the CGRP receptor. And thereby we see a very high response to CGRP in our setup. And when males get older, testosterone levels decline, and we expect maybe a lower response to CGRP, which is what we see.
That is so interesting, and it's probably will have some practical implication for all of us, what medications we choose in the future, but we need more research. So what is next for you? I hope you don't stop.
I think this research was, of course, very interesting, but it also raises a lot more questions that need to be investigated. So for now, we hypothesize this effect of sex hormones on CGRP levels, but I think this should be investigated in depth. So really see what if we add estrogen, how does this change CGRP? But also maybe in like a cellular model, look at CGRP receptor expression. And if we add testosterone, does this change? So I think these are the next steps that we really need to dive into these mechanisms. So what do sex hormones do to CGRP levels and CGRP receptors? And another thing that really needs investigation is now we only looked at, well, we don't even know the disease status, but a general group of men and women. And we would, of course, want to know whether migraine patients show different responses. Unfortunately, our data now is anonymized, but hopefully it's possible in the future to also get tissues from migraine patients and then see their CGRP response to see how they fit into the data. I think these are
That is fantastic.
Yes.
Yes, yes, and it's so great to see this wonderful teamwork and so much great research done with so much effort, and it will benefit all of us. Anything you would like to add, Professor Maassen?
No, I think Tessa made a very good summary of our results and the implications of the findings. I think what's nice is that the topic of migraine and women and hormones, was an under-recognized topic, and now it became to get a bit more attention. But I think what is lacking is still really robust biomedical data. And I hope very much that this study adds to it, because it's really not just a matter of perception or that women complain more, but there are really other things going on in these women. And I think this is a little start, but at least a first step to really understand what's different in this matter, women. And of course, yeah, we hope that it will provide insights in how to tackle this problem in women.
Wow, this is fantastic. Thank you so much. And I really hope that we will see both of you again soon with more wonderful research. Thank you from all of us, and we'll see you very soon.
Okay.